Hello class, today we will discuss about classification of aggregates. You can classify the aggregate in the different way. Let us understand with classification of aggregate based on a unit weight. So, based on the unit weight, you can classify this aggregate in three ways like normal weight aggregates, lightweight aggregates, heavyweight aggregates. So, what is the normal weight aggregate? The density of the aggregate is between the 2200 to 2400 kilogram per meter cube, which is the known as a normal weight aggregate. What is the lightweight aggregate? The density of the aggregate is less than 2200 kg per meter cube is known as a lightweight aggregate. What is the heavyweight aggregate? The density of the aggregate which is more than 2400 kilogram per meter cube is known as a heavyweight aggregate. So you can classify the aggregate based on unit weight. So let us understand normal weight aggregates. You can also classify the normal weight aggregate in two ways. First one is a natural aggregates. Which are the natural aggregates? Sand, gravel, crushed rock as a granite, basalt, quartzite, sandstones. These are the natural aggregates. Next one is a artificial aggregates. Which are the artificial aggregates? Like broken bricks, air cooled slag, sintered fly ash, and a blotted clay. You can see in the photo also broken brick and blotted clay, and you can see aggregates like sand and gravel in the photos. So this classification for particular normal weight aggregate. The main classification is derived by the normal weight aggregate, lightweight aggregate, and heavyweight aggregate. In the normal aggregate, you can classify the natural aggregate and artificial aggregate. And now let us understand the lightweight aggregates. You can also classify the lightweight aggregate in two ways. First one is natural aggregates like pumice, scoria, rice husk, sawdust. You can see in the photo, this is the pumice, and this is the scoria. This is the rice husk. This is the sawdust. These are the natural aggregates available which density is less than 2200 kg per meter cube. And next is artificial aggregates like flamed slag, you can see in the photo, bloated clay, you can see in the photo, expanded cell, and sintered fly ash. So these are the artificial aggregate for particular lightweight aggregates. So also you can classify the lightweight aggregate in the two way, natural aggregates and artificial aggregate. In the natural aggregate, pumice, scoria, rice husk, sawdust, and in the artificial aggregates, formed slag, bloated clay, expanded cell, and sintered fly ash. You can get the more pictures of this type of the aggregates in online on the in the Google search. By the Google search, you can get the more pictures. You can identify the how they are uh, look as a physical. Heavyweight aggregates. So heavyweight aggregates, we can, which are the heavyweight aggregates? The density of the aggregate which is the more than 2400 kilogram per meter cube is known as a heavyweight aggregate. And heavyweight aggregates are barite, limonite, magnetite, hematite. So these are the pictures of the barite, limonite, magnetite, and hematite. So these are the photos of the heavyweight aggregates which density is high compared to the normal aggregates, and about the light aggregate, which density is low compared to the normal aggregates. Next classification based on the size. This is the most important topic. You should know that what is the coarse aggregate and what is the fine aggregate. What is the fine aggregate? The aggregate size which is less than 4.75 mm is known as the fine aggregate. Next, what is the coarse aggregate? The size of the aggregate which is more than 4.75 mm is known as the coarse aggregate. In the concrete mass, the coarse aggregates provide the strength to the concrete mass, and void of the coarse aggregate filled by the fine aggregate, clear sand, fine aggregate, which is the as of which we are providing, which we are adding to the concrete mass for as a only filler material. And what about cement? This provide the binding property. So coarse aggregate, fine aggregate, and cement mass. Clear? So you can get the different sizes we are using in the concrete mass. Clear? So bulking is more. When you add the water mass, the bulking is more in the fine aggregates, and in the coarse aggregate we can neglect this type of the problem. And fine aggregate fills by the voids between the coarse aggregate, and the coarse aggregate gives to strength to the concrete mass. I repeat again, coarse aggregate provides the strength of the concrete, and fine aggregate fills to the coarse aggregate voids, and cement fills to the voids of the fine aggregate. Coarse aggregate provide the strength to the concrete mass. Fine aggregate we are using in the concrete mass as a filler material, and cement we are adding to the concrete mass for as a binder material. Clear? Now you can get the uh, actual the ingredients of the concretes are working. And fine aggregate like natural sand, crushed stone, crushed gravel. What about coarse aggregate? Gravel, crushed stone. Which size is more? Which size is greater than 4.75 mm? And natural sand, which size is less than 4.75 mm? So this is the most important thing, most important classification based on the size. Next classification based on the shape. The different type of the shape affect to the property of the aggregates. Property of the aggregates will affect to the property of the concrete. Which property? Like fresh property, hardened property, and it also affect to the durability of the concrete. Let us understand which are the different type of the aggregates based on the shape. First one is a rounded aggregate. Second one is a flaky aggregate, elongated aggregate, irregular aggregates, and angular aggregates. We can see in the photo. First one is the angular aggregate. This is a naturally shaped and rounded aggregate. You can see the shape of the aggregate is round. Flaky aggregate. Flaky aggregate means the thickness of the aggregate which is the thick, thin, and uh, this photo shows the type of the aggregate, flaky aggregate. Clear? Which thickness is less than 60 percentage as compared to the mean dimension of the aggregate. And elongated aggregate, you can see in the photo the length of the aggregate is more, means which length of the aggregate is more than 180 percentage as compared to the mean dimension of the aggregate, so it's known as the elongated aggregate. And you can also understand in this photo rounded aggregates, this is the angular aggregates, this is the flat flaky aggregates, and this is the elongated aggregate. Clear? So these are the aggregate based on the shape. This will affect to the property of the concrete mass. There is different type of the shapes you are using in the concrete mass, and this will affect to our concrete mass, like fresh property of the concrete, hardened property of the concrete, and durability also. So let us understand in detail rounded aggregate. Rounded aggregate, which is fully water worn and completely shaped by the adhesion. You can see in the photo. These, these are the rounded aggregates and contains minimum voids from 32 to 33 percentage, and it gives the minimum ratio of the surface area to volume, thus requiring minimum cement paste to make good concrete. It's required minimum cement paste because the void ratio is low, and it gives the better workability because the rounded aggregate, which is the easily they can provide the smoothness between the particles, and they can give the workability, best workability of the concrete mass. The interlocking of the particles is less. This is the disadvantage of the rounded aggregate. The interlocking is poor, hence the development of the bond is poor. It means the unsuitable for the high strength concrete. You can use this aggregate in the normal weight aggregate, but you cannot get the high strength in, for particular high strength concrete. So this is the disadvantage for uses of rounded aggregates. Examples of the rounded aggregates are a river or seashore gravels. Generally you are getting the rounded aggregate from the river and seashore gravels and desert and wind blows sand. This sand formed by the wind. Clear? So rounded aggregate has the low void ratio, and it gives the higher workability but uh, bonding low bonding is formed by this aggregate, so it cannot be used in the high strength concrete. Next one is irregular aggregate. Irregular aggregate naturally or partially shaped by the attrition and having the rounded edge. You can see in the photo the rounded edge but irregular in shape. Contain higher percentage of the void ranging from 35 to 38 percentage, and it's required the more cement paste for the workability. You can understand that the irregular shape and the void ratio is high, and it required the more cement paste for the higher workability, and interlocking between the particles better than the rounded aggregates. In it can be used for the high strength concrete. You can understand that it's required the high water paste, and void ratio is also high, 35 to 38 percentage, and you can use in the high strength concrete because the interlocking of the particles is good compared to the rounded aggregates. So irregular aggregates examples are pit sands, gravels, land dug flints, and cuboid rocks. So these are the example of the irregular aggregates. Next one is the angular aggregates. Angular aggregates has well-defined edges formed at the intersection of the roughly planar faces. You can see in the photo, roughly planar space faces and irregular edge, and maximum void ratio and maximum percentage of the void is ranging from 38 to 40 percentage, which is very high compared to the rounded aggregates, and interlocking between the particle is very good, and thereby providing in the good bond. It means you can use in the high grade concrete. So they requires more cement paste to paste making and for the workable concrete, and you can use in the high strength concrete. The angular aggregates are suitable for the high strength concrete and pavement subjected to the tension also. Clear? For example, for angular aggregates, crushed rock of the old types, talus. So you can get the angular aggregate by the crushing of the rocks. This is a simple example. Clear? Next, flaky aggregates. This is the one of the type of the aggregate. Flaky aggregate. What is the flaky aggregates? Aggregate whose least dimension. What is the least dimension in this aggregate? Thickness. Thickness is the least. It means the thickness is less than 60 percentage mean by the terms as compared to the mean dimension of the aggregate is terms as flaky aggregate. You have to take the thickness and then you have to compare the mean dimension of the thickness, and it if the thickness is less than 60 percentage of its mean dimension, it means it's this aggregates is flaky aggregates. Clear? The mean dimension of the aggregate is the average of the sieve size through which the particle pass and return respectively. They reduce the workability of the concrete. If you are using the flaky or elongated aggregate, so you will get the problem regarding workability or the fresh property of the concrete. The flaky aggregates can also affect the durability of the concrete. Remember the one thing, that it's also affect to the uh, durability of the concrete, and they also reduce the strength of the concrete. It means if you are using if you are using the certain more than certain percentage of the aggregate, it will affect to the fresh property, hardened property, and durability of the concrete. For example, if you are using the more than 15 percentage like this flaky aggregate in your concrete mass, you will get the uh, effect on workability or the fresh concrete or hardened property, strength of the concrete, and durability of the concrete. Clear? So you should not use this type of the aggregate more than 15 percentage. Clear? Examples for flaky aggregates are laminated rocks. Clear? So these are the main properties of the flaky aggregates. Remember that you should use this aggregate. You can use the aggregate less than 15 percentage. Elongated aggregates. Elongated aggregate means the greatest dimension in the aggregate. The greatest dimension is length is greater than 180 percentage of mean dimension is known as the elongated aggregates. Clear? So they also reduce the workability of the concrete like flaky aggregate, and it's also effect to the durability and the strength of the concrete like flaky aggregates. And same percentage criteria for the elongated aggregate, you cannot use more than 15 percentage in the concrete mass elongated aggregates, otherwise they will affect to your fresh property or the workability, strength of the concrete or the hardened property, or durability of the concrete. For example, laminated rocks. These are the flaky aggregate, thick particles, and elongated aggregate, which is the length is which length is more.